Hello, welcome back to Cracking the Cryptic and the return of Rocky Roa, who I seem to remember is a math teacher, and the puzzles often involve a certain amount of arithmetic at least. We'll have a look at this. It's been highly recommended to us, and I want to give it a go. There are two versions of the puzzle, one with an outside perimeter for writing in and one without. I thought we'd use the one with the outside perimeter because people sometimes complain when there isn't such a thing in puzzles that can use those. Anyway, first of all, don't forget that on Patreon we have loads of content like monthly Sudoku hunts, like solution videos to those monthly Sudoku hunts, like connections videos every few days, crossword videos monthly, all sorts of stuff, some long solves and things. It is very much a place to go for extra stuff around the channel, as are our apps, which are fantastic. We have loads of apps, including Line Sudoku and Sandwich Sudoku, which is relevant to today's, and Arrow Sudoku. But the latest is Fog of War Sudoku, and very popular it is too. Now, there's also our merchandise, like this wonderful mug. And there's SVEN'S SUDOKU PAD. They're all on the links under the video. Do check them out. The first link, though, is to this puzzle. If you did want to play a version of the puzzle without the perimeter, you could look up Rocky Roa on Logic Masters Germany and find a link to that. Anyway, I'm going to explain the rules. So, normal Sudoku rules apply within the 9x9 grid. So we're going to put 1 to 9 in every row, every column, and every 3x3 marked region. Now, this is a sandwich Sudoku, so numbers outside the grid must be deduced and are the sum of the digits between the 1 and the 9 in that row or column. Now, every possible row and column from each direction can have one of these sandwiches. So let's just randomly imagine a set of digits in this column. The digits sandwiched between the 1 and the 9 are those. They add up to 12. Oh no, it's not from each direction. What am I talking about? It'll be the same from both directions. And so some of these on the dots outside the grid have sandwich values. Now that's going to prove interesting as we get to the white and the black dots. First of all, crop key arrows. Numbers separated by a white dot have a difference, not a difference of 1, but a difference equal to the value of the white dot, which is the sum of the numbers on the arrow attached to that dot. So the difference between yellow and blue is a number, and that number is the same as the sum of all of these cells. So the white dots represent the differences that are the sum of the arrows. Don't tell me. The black dots, numbers separated by a black dot have a ratio equal to the value of the black dot, which is the sum of the numbers on the arrow attached to that dot. So if these numbers added up to 7, the ratio between those digits would be 7 to 1 between those numbers. The number outside the grid can, of course, be a 2-digit number. Now, there's another note here that for the answer check to work, we shouldn't fill in any numbers in full size outside the grid. So we'll have to bear that in mind. That also tells me that if you normally play with the conflict checker on, I think it may not work for this puzzle, so you probably ought to turn it off, I'm afraid. Because it'll react, I think, to candidates outside the grid. I don't know. Anyway, certainly if you put full numbers outside the grid, it might react to them. It's a complicated rule set in a way, but it's a very simply presented puzzle, if you see what I mean. I am going to get started. Let's get cracking. You can try it on the first link under the video. Now, do we start with black or white? Do we start with very long or very short arrows? I just don't know. I'm going to start with this one because the ratio that this represents is the sum of these digits, which must be at least 15. Now, okay, I'm going to tell you some things I know about sandwich numbers outside the grid. They can be 0, and I don't know if that's going to be relevant today, but they can be. If the 1 and the 9 are next to each other, you can get 0. You can't, however, have 1 as a sandwich sum because it counts the digits between the 1 and the 9, and that can't include the 1. The maximum is 35. If you had the 1 and the 9 at each end of a row, the digits in between would be 2 to 8. They add up to 35. So sandwiches are either 0 or from 2 to 35. And I feel like that difference of 1, now it probably won't matter here, but this surely can't be more than 1 or 2. If this adds up to at least 15, what could you multiply that by? Well, to get a workable ratio that leaves a number here that's no more than 35. And is that the right question? Am I even asking the right question? I don't know. I'm sorry. I've got to work this out. It's not what you multiply. Yes, it is. It is. I think this digit has to be 1 or 2. If these add up to exactly 15, that 1 or 2 times the 15 is the sandwich sum. So in that case, if this was exactly 15, this would be 15 or 30. If that's 2, this could be 32 or 34. And these could add up to 16 or 17. If it's 1, it can't be 1. It can't be 1. Okay, I think I can work out that that is the case. If this was a 1, this would be both the ratio. Well, it would therefore be the sum of the arrow cells, but it would also be meant to be the sandwich in the row. Now imagine these were 2, 3, 4, 5, adding to 14. That would make the total 15 for the arrow, and this digit would be 15. So what you'd have to, we would have the 1 here, and then you'd have 2, 3, 4, 5, and then you'd need another 1 to make up the arrow to the same total, and the 9 here. My goodness, so that is a 2. These add up to either 15, 16, or 17, and this digit is now 30, 32, or 34. I'm going to write it like that. It is either 30, 32, or 34. This adds up to 15, 16, or 17. Now, it's not 34. In fact, I should have said when I was going through what the possible sandwiches are, 34 is not possible because that would exclude 1. What you start doing when you're thinking of the high numbers, like these 30-somethings as sandwiches, is if the sandwich adds up to 34 and the crusts, the 1 and the 9, I know they're not crusts, they're the pieces of bread, but that's the terminology we use. If they add up to 10, that's 44. Then you'll have outies, digits that fall outside the sandwich, and they would only add up to 1. 34 is not possible. Now, if this was 32, that's not going to work either, because the outies will add up to 3. 35 minus 32 is 3. But the outies would include a 2. So then the outies would have to include a 1. And they're not allowed to. So that is 30. This is a 15 arrow to make the to make the ratio 15. And now we have to put everything between the 1 and the 9, apart from 2 and 3. The outies add up to 5, which is 35 minus 30. We know that 2 is one of them. The other one is 3. It must sit here, since 3 is on this arrow somewhere. This is then 1. Look at that. We get 3 of the digits actually placed. And this is 9. Now, that's interesting here. So, this is either 8 or 10. which I'm going to write like that. I know it's a bit confusing, but no, it's not 8 or 10. I've forgotten the rule. This is not a regular white dot. This white dot represents a difference of whatever's on the arrow, which is now somewhere between 19 and 35. 9, 1, 2, 3, 4, and 9, 8, 7, 6, 5. I'm sorry, I'm just going to put them in while I think of it. So the white dot represents a difference of somewhere between 19 and 35. Well, it can't be anything like 35 because that would put, this is a big number here. This is at least 28, and it's somewhere between 28 and 35. Okay, I'm not pencil marking that. I'm just going to remember that this is between 28 and 35, and that is the sandwich sum, and that must contain at least 28 would be at least 8, 7, 6, 5, 4 is 30. Okay, at least 5 digits are in the sandwich. So those are in the sandwich. The 1 is down here somewhere. Now, I don't think the 1 is here because then the sandwich would be 35. That would be the number here. The difference would be 26. Oh, and that would mean that this arrow added up to 26. Okay, actually that's not a problem. Didn't really get very far with that. Is there any point painting this red and green as I would normally do for a sandwich? Sudoku, not sure. I will start it and we'll get rid of it if it doesn't really help. Okay, I'm going to look at this weird 1 cell arrow now. So this digit is 6, 7, or 8. And that is not only the number that will appear in this cell, but the value of the white dot. So the difference between these two is that digit. Now that means either the sandwich sum is 0, and don't forget that possibility, or it's double this. So then it's 12, 14, or 16. And actually, I don't think that's enormously helpful. Extraordinarily. Now we have two arrows in the same row. Now, as I discovered whilst doing the intro, these digits are these numbers are the same because they represent the same sandwich value of the row. What does that mean? My goodness, I don't know. It means that the difference... Oh. These numbers are the same. Oh no, the differences are different. The difference here is the value of that arrow. The difference here is the value of that arrow. Oh gosh, I don't know how to use that at all. Wow, I'm finding this mighty confusing. Okay, I'm going to look at a black 1 cell dot. So I think I sort of understood how these white dots work based on that, the white 1 cell dots. This is either 0 or 2 times whatever's there. Now, how does it work on black? If that was a, well, let's go through all the digits. If that was a 1, the ratio would be 1. That would be a 1. That's impossible. So this is not a 1. If it was a 2, the ratio would be 2. So if you divided that cell by the ratio, you would always get a sandwich number of 1, and that is not going to happen. So instead you're multiplying the digit in this yellow cell by itself, because that is the value of the black ratio to get this number. So this pink number is a square of yellow. Right, well it's not, oh no, it could be 2. But we can't go up, well, we can't go to 36, which is the square of 6. So this is 2, 3, 4, or 5. And this is 4, 9, 16, or 25. Now, if that was a 5 and this was 25, the outies would be worth 10, but they would already include a 5 and at least a 6, so that's not going to work. It's not a 5. It's either 2, 3, or 4, and this cell is 4, 9, or 16. This number, and that's going to represent the sandwich in the column as well. If it's 4, we must have a string of 1, 4, 9 somewhere in the column. If it's 9, there are various possibilities. If it's 16, again, various possibilities. I mean, this really is all about selecting the right clue to work on, and I'm not sure I'm really getting much of that done. I think that was the good one to start with. Right, let's have a look at a 3-cell black dot clue. So this 3 digits can add up to somewhere between 9 and 24, which, because the 1 has gone in this column, which represents this ratio. Now there's no point dividing. Even if I put a 9 there and divide it by 9, I'd get a sandwich sum of 1. So this digit, this orange, is somewhere between 9 and 24. No, it's the multiplication by this digit, which is not a 1, of somewhere between 9 and 24. Right, I'm going to say that is 2 or 3. Because if you multiplied 4 even by the minimum 9, you'd get to 36, which is too big for a sandwich. So 2 times 9, say, would give you 18, but this ratio could be more. 3 times 9 would give you 27. But the 9, if this added up to 9 in that situation, 3, 2, and 4 is 9. You could put the 9 here. Can you cram 27 in there? You'd have 8, 7, 6, 5 left, which specifically add to 26. In fact, no. 9 plus 9 plus 1 is 19. You've only got 26 left in the column. So I don't think 3 can ever work. If this... what if 9 was on the arrow? So then the minimum value of the arrow 392 is 14. 3 times 14 is 42. That's too big for a sandwich. This is definitely a 2. That rules 2 out of this cell and 4 out of this one. I think it may stop doing much, because we don't know what this ratio is. This arrow could... can 9 be on it? Again, it's 293 as the minimum, but now we're multiplying 14 by 2. To get a sum of 28, for which the outies would be 7. So that specifically won't work, because the outies could only be 2 or 2 and 3. However, it makes me think that 249 might work. 249 would add up to 15. This would be 30. Oh no, now the outies would be 5. So that doesn't work either. So I don't think 9 can be on this arrow. And now, the furthest away that 9 can be is here, but we're definitely having to get to a sandwich of at least 18, which is at least 3 cells. So 9 is in one of those 2 in the column, because the sandwich is at least 3 cells, and they add up to at least 18. Now, if they added up to 18, because these added up to 9, that would be 27 plus 1 is 28, plus the 9 is 37, and an 8 in those cells. And the 8 would be here. So the 9 would be there and the 8 would be here. Let's try it as this adds up to 10, then this adds up to 20. What I should really do is work out, can the 9 be here? If the 9 was here, this sandwich is double the value of this, because it's the orange number. They would add up to 10. The remaining digits in the column add up to, you see, this is where the maths suddenly comes in and is extraordinary. The remaining digits in the column, apart from the 9 and the 1, add up to 35. Is that divisible by 3? No, it's not. It's 5 times 7. And the reason I care about it being divisible by 3 is if the 9 was there, that area would be 2 times that area. So if you call that area x, all of those cells are 3x, but they can't add up to 35. So I think the 9 has got to be here, which is weird as a calculation. Or it's weird that the calculation can give me that based on factorising 35. That's so odd. Now, it does perhaps tell me what the possibilities here are, because again, this group of cells is now the group that is divisible by 3. So amongst these 7 cells, we have 35. This group is divisible by 3, so it could be 33 if that was 11, and that would leave a 2 here. That's not allowed. It could be 30 exactly if that was 10, and that would put a 5 here. If this was 9, then we'd have 27, and the 1 9 is 37. That would be an 8. So we're moving up in increments of 3, 2, 5, or 8, and we end there because we can't put an 11 in this cell. Now, how did we get the 5 possibility? That was if this added up to 10, 30, 40, 5. That's not going to work, because for this group to add up to 10 without a 1, it would have to be 2, 3, 5, and that would counteract the 5 there. This is an 8. These add up to 27, and these add up to 9. And this sandwich sum is 18, and it's definite now. And these are a 3, 4 pair to make this add up to 9. And this group of cells is 5, 6, 7. This is so strange how this is working. It's very, very clever. Right. Do I look at that or that? Probably this. Black dots seem to have been quite powerful here. Now, I've lost the ability for this to be a 2, obviously. I don't think it can be a 1 for exactly the same reason this couldn't be, because the sandwich would be the total of this arrow, but the 1 being there would mean that you couldn't make up the total of the arrow. You would overlap it by -1, and that would have to be a 1 in the sandwich. It's just not possible for the same reason as up here. So if you understood the reason that couldn't be a 1, you understand why this one can't be. If you didn't, you'd better go back to that bit of the video. Now, this can't be a 2 anymore. So this is at least 3, and that means the sum of these, which is an absolute minimum then of 9, multiplies by that 3 minimum. And in fact, now it can't be 4. This has to be 3, because if that was a 4, this would actually have a minimum of 10. Multiplied by the 4 would give 40, which is far too big to be a sandwich sum. So that is a definite 3. And we're either multiplying by 9 or 10. There is a way for it to be 11. And that's it, because that takes us up to 27, 30, or 33. And we can't go to 36 as a sandwich sum. Now, we can't even go to 33, because the outies would only be 2, but we've already got 3 amongst the outies. What I think I'm working on is that this has to be a 1, because we have to form a big sandwich. In fact, if 30 Yeah, 30 would work, as long as you had the crusts there and another outie of 2. So the outies are either 35 minus 30 or 35 minus 27. They either add up to 5 or 8. And they include 3. So the remaining outies either add up to 2 or 5. And they can't include the digit 1. So this is the remaining outies. It's either a 2 or a 5. And these are the crusts, the red cells. And that one is a 1 because we've got a 9 in the box. That is a 9. And then we are multiplying up 9, 10 or 11 by 3 to get 27 or 30. Well, that's only 9 or 10. So that's 5 or 6. Oh, and if it's a 5, does that lead to this being a problem? 9 times 5 is 27. 27, 37, yes. 30. Hang on. Yeah, if that was a 5, this would add up to 9, and that would be the black multiple value. 3 times 9, this would be 27. These would add up to 27, plus these reds is 37, plus that is 40. So I started off, if that was a 5, we would get another 5 in the row here. So that's not a 5, that's a 6. That's 10. This sum is 30 here. These add up to 30, plus the reds is 40, plus 3, this is a 2. Wow, and these are 4, 5, 7, 8. I'm just so impressed by this. Right, now surely I can look at this. I guess there are 6 permutations of those 2 digits, if you don't worry about which one's sitting where. But you have to worry a bit about which one's sitting there because of the white ratio. So, and where are 1 and 9 in this row? They are at a maximum distance apart there, containing 7, 6, 5. 18 is the absolute maximum sandwich, which is this digit plus the white cell, the white difference value, which is all of those. So to get a maximum of 18, we're doubling this and adding those 2. That is a minimum 4. Double it to get 8, plus 8 is 16. That has to be a 2. That's it. That's the absolute maximum. So 4, 2 and 8 add to 14. That makes this 18. Yeah, 0 was never an option because you're subtracting all of those digits from that one. That's fine. Just wanted to check that. 18, and that is what you're going to squeeze between these red digits by being 7, 6, 5. Look at that. This is crazy. And that's a 3 by Sudoku. Now we can study this. There's only 3 permutations here. And we're multiplying by, no, we're adding to 3. Was I adding here? Yes, I was. Good, I was doing the right thing. Right, so this arrow now adds up to, well, we know that the sum is 18, obviously. So what I could do is subtract the 3. The difference is 15. This arrow adds up to 15. We've already got 4. These 2 add up to 11. They're 5, 6, and that's a 7. And thank goodness it works. Right, 7 comes out of those cells, and that becomes a 7. 5 is in one of those cells, so that sorts out the 5, 6. And we are rocking now. I suppose we've looked at most of the arrows, but certainly not all of them. We've still got some weird cogitations to do about the arrows. Right, these are all green. I'm not sure the colouring was really doing much anyway. Well, mind you, it's going to do something here because we've got one of the crusts. But with a single cell arrow, this could be 0. I have a feeling that's going to be important. Actually, maybe it means we shouldn't even approach that. We should look at this. I don't know. I don't know which we should do first. Oh, I never figured out this one. Oh, this is interesting. Let's go back here. This had, it had a sandwich. Ah, yes. One of the possibilities was 0 for this one cell arrow. Well, that ain't going to happen on this column because one of these two cells is a 1. One of them is red. Colouring is actually helping suddenly. But we can't put the 9 there, so the 9's down here. So this group is in the sandwich. And the sandwich has to add up to, I think it was double this, 12, 14 or 16. Well, one of those is absolutely minimal, 16. So 7, 4, 5, that is 16. This must be an 8. Those are the sandwich, so these two are red. And away we go again. We get a 1 and a 9. That's not a 1, it's green. These are green, and 3's are green. And the remaining digits in the column are 2, 3, and 6. And that's another arrow done. Now, this one, let's go back. Revisiting arrows seems to work, or it worked on that one. This one is either a sandwich sum of 9 or 16. Now, I was going to say, could they all be in the sandwich of 16? They couldn't all be in. If that was green, yeah, this is the question. Is this cell green or red? If it was green, it wouldn't be 1. The minimum value of these things would be 12. So 16 would be the sandwich sum, but that would be a 4, and then the minimum value would be 13. And I don't know the answer. That's possible. But the other question is, what if this was red, you couldn't get to 16 in 2 cells before you hit the other red, either up or down? If this was red, therefore, this would be 9 and this would be 3. And then you'd be making a sandwich sum of 9, which couldn't be 6, 3, because you'd have a 3 here. So it would have to go up. You'd have a 1 here and a 9 here, and this would be a 4, 5 pair. Now that does look possible, and you'd have used 3 down here, so it's not ruled out. Okay, that is one way that this works. If the sandwich sum for the column is 9, and you do that with a 1 here and a 9 here and a 4, 5 pair in between. The alternative is that the sandwich sum is 16, and then these are all in it. And that's a 4. So these are at least 6, 5, 2. But they could be 6, 8, 2 and add up to 16 on their own. So there are still options, annoyingly, in column 6. And we're going to either have to do this one or this one. Let's have a look at this one. Now, I'm concerned that whatever we put in here could subtract to a 0, and that's just fulfilled if one of these is a 1. Alternatively, it adds, and just like up here, we double it. If that was a 3, then the sandwich sum would be 6 in the column, which would require 9, 6, 1, I suppose. If it was 4, the sandwich sum would be 8. I mean, there's a lot of optionality there. That's not so good. Right, I'm going to have to look at this. Ah, okay. This digit is not now 2, 3, or 4. I don't know what it is, but that might be interesting. So this time we can't have a difference of 0 because the arrow is 2 digits. It's not just that one. So what we have is a sandwich value that is double that digit plus that digit, because it's the difference between that digit and the sum of those two. So you're adding to that, you're adding the sum of those two. So it's twice that plus that is the sandwich value. And that is 5, 6, 7, 8, or 9 in this column. So it's at least, well, you're adding this and double that. So you're getting to a minimum of 7 as the sandwich value. Now, if that was a 1, if that was a 1, the 9 couldn't be any further in the row than that. But the sandwich value would be 2 plus this digit. It would be 7, 8, 9, 10, or 11. Oh, but if that was a 1, let's just, I think this would have to be a 2. If that was a 1, let's say this was a 5, that would be an arrow of 6, and therefore a white cell value of 6. This would be a 7, and after the 1 and the 5, you would need exactly 2. This can never be a 1. Aha. So now the arrow adds up to at least 11, plus that value again. We're up to 16 minimum of the sandwich value. I'm wondering if it's going to force the 1 into that cell, but it doesn't. What is the maximum sandwich value? Is double 9 and an 8 is 26. Right, I don't know. I was going to say I don't think this can ever be a 9. That's so wrong. It could be a 9. Or could it? If that was a 9 and this was a 5, the sandwich value would be 23, starting with 5 and 3 or 4. Five, 3, 7, 8, and then a 1. It does just work. And that's probably what it is, but oh, I don't understand how to proceed. I don't understand. I don't know. It doesn't look like I can make headway with that one, with this one, or with this one. And there's nothing else amongst the clues. Is there Sudoku that I can't see? I don't think we've done enough. Oh yeah, no, hang on. This arrow, we know... I never finished off this column with a 1. Oh, this is important. Right, I'm sorry, never finished off this column. That 9 adds to the value of this, which is at least 6, 2, 4, 5. This pair sees 1, 2, and 3. 4, 5, 6, 2 are the minimum values here. They add up to 17, plus the 9 is 26, plus the 9 again is 35. There we go. That is what is going on here. That is 35. This is the 1 down here. Now, that gets quite interesting for one of those rows, row 8. We'll look at that in a moment. But we now know that these are 4, 5, 6. So that's a 4, 5 pair. That's 6. And what are we left with here? 7 and 8. These can't be 8. Right. Now, in this row, the maximum sandwich, if this is 9, well, if 9 is not on this arrow, 9 and 1 are squeezed in there with a maximum sandwich value of 8. But that has to equal twice that plus that. That's not possible. So 9 is on the arrow. Then I can place 9 in the bottom row. Might as well do that. Don't know what it's going to give me, but it's the truth. Now, if that was a 9 and this was somewhere between 5 and 8, then we're looking at a sandwich of 19 to 25, i.e. outies of 10 to 16. Oh, that does look possible. It is, well, it's just possible to be 25 with 9, 8, 7, 6, 4, and then the 1 here. Okay, if 9 is here, that's what I was doing. If 9 is here, we're looking at a minimum of 23 with outies of no more than 12. That would have to be 732. What was I saying? I was saying if 9 is here, 2 9s and a 5 is a minimum value of 23 for the sandwich. The outies would be 12. They would be 9, so we'd have 9, 5, 7, 3, 2 there, 1 there, 4 there, and a 6, 8 pair. That does just work. Oh, I can place 1 in column 1. I don't know that this is, I don't think it's doing anything, but it's assuaging my nerves to do a bit of colouring and filling in numbers. That is actually quite interesting, making that green for this column. I seem to remember there was an absolute, if this was 16, these are all in it. It would have to be 6, 2, 3, 5. That still works as well. That would need a 1 here. Now, if it was 9, that was going to be a 4, 5 pair up here. And that still works as well. That doesn't need this to be 1. Right, is this arrow going to force this to be 1? So the absolute minimum value here is double 5 and a 9 is 19. But then the 9 is here. And you've got to have at least 3 cells. If the 9 is here, the minimum value is 23. And you've got to have at least 4 cells of sandwich. The 1 is always here in row 8. And now we know that this is not working on a sandwich of 9 because this can't be a 1. This is green. Where would you put the 9 sandwich? We're working on a sandwich of 16 that uses all those 4 cells. Oh, clever. And they are 2, I think they're 2, 3, 5, 6 to get this set. Well, that's a 4. So yes, the minimum is now 2, 3, 5, 6. There we go. And that's a 7 at the top. That's an 8. That's a 6 by Sudoku. That's not a 6. Oh, it's madness. Right, now in this column, this digit is not allowed to be 1, 2, or 4. The sandwich can always be 0 here because you could subtract this digit again to get 0. Can it ever be double that? If the sandwich was 6, oh look, these are green now. The sandwich has to go north. Oh, these are green because they see a 1 as well as a 9. Right, the sandwich is either 0 or it's those 3 cells adding up to 6, 10, 12, 14 or 16. And that wouldn't be a 1 in this situation. That's quite difficult to rule on, I'm afraid. Oh, no, I'm going to have to come back to this one or do Sudoku. I like doing Sudoku. Can I do more Sudoku? Less maths. Oh, goodness. I feel it's so likely this is a 0 and that's a 1, but I haven't done that. Have I? No, I hadn't finished that off, but I have now finished off this pink one. And I've finished this off. Yeah, all the clues. Oh, I can take 5 out of those cells. Might be interesting for for this sum, although I don't think it is yet. Right. These are from 237. I'm really just trying to find a Sudoku way through at this point. 4's in one of those cells. Now, I've got to look at this again. So, if that was a 9, the minimum value of the sandwich is 23. 9 and a 5 there. And the 5 is contributing to the sandwich, and that is, and I think it's either 5387 or 5486. And we're always using the 8 in that case. And that's got to be the minimum. If this was 99 and a 6, we'd be looking at 24, including the 6. These would add up to 18 again. Well, it's the same again, 387. Oh, 87 won't work. Right, if that's a 9, this is going to have to be a 5. Because 9 and 6, which adds up to 15 plus the 9 gives you a 24 here. And to get 24 with a 6 there, you can't put a 4 there, or you'd need to repeat the 6. If you put a 3 there, you get 8, 7 there, and that kills that cell. Right, if that's a 9, that's a 5. Now, alternatively, this is a 9, and we're doubling this digit. But then we've got to keep the sandwich down to here. So if that's a 9 with a 5 there, then we've got to make this add up to 19. We're not allowed 4, 7, 8, because that'll break that cell. We would have 3, 8, 6. And if this is a 6, I think we're bust here. 12 and 9 is 21. You can't fit 21 in there. The maximum is 19. Right, this is a 5-9 pair. That's so strange. Beyond that, we've got either... so strange. We've got either 23 or 19 here. But if it's 19, it's just those 3 cells. Is it 19? Is that? Yeah, that is what I mean. If it's 19, that's with a 5 here and a 9 here. These 3 would have to add to 19. That is not possible at all. 8, 7, 4. And that would break this cell. Wow, it's all about this cell. Okay. So it is not 5 there and 9 here. It's 9 here and 5 here. And we are looking at a sum of 23 over here. And that includes this 5. Then these add up to 18. And they can't have 8, 7 here. So they have 8, 6 here and a 4 here. And that becomes a 7. And in this row, we now have a 2, 3 pair here, I think. And that becomes a 6 by Sudoku. And there's a 5 and a 4 to go in there. Now, this digit can't be 5 or 6 or 8 now because of the 6, 8 pair. It's 3 or 7. This is either 0, 6 or 14 as the sandwich in this column. Well, it's not going to be 6 because that would include all 3 of those cells. So, well, that doesn't mean this isn't a 3 because that could be 0. But it's not 6. So the sandwich sum in this column is either 0 with a 1 there or 14 with a 1 there. Now, how would you make 14 here? And that would have a 7 here as well. I don't know. I'm going to try and do Sudoku instead. Sorry. Sorry to Sudoku haters. I don't know why they're watching the channel. 6 is there in this row. That's a 5, 7 pair. Oh, this has become a 3. Well, this has to be a 0 now. I was going to write it in as a full 0, then remembered that we're not allowed to get the answer check to work. That is now the 1, therefore, and we did get a 0. That's green and is a 2. This is green, and it just doesn't really matter. This is about the colouring anymore because I haven't got any more sandwiches to do. I've just got Sudoku to do. Can't tell you what a relief that is at this point. I think we're right, and I think we're going to finish the puzzle, but I haven't been quite so unsure for a while. 3 there, that's a 2-6 pair. That sorts out 8-6 and 8-4 and 4-5 and 5-7. Did we get the 7? No, that's not a 3. We didn't get much done here. No 6 here. This pair is 7 and 8. Why am I still struggling around? Is there something I didn't finish off? What's going on in this column? 5. No, it's just Sudoku. It's okay. We need a 4 in column 2. There it is. That's going to sort out 5-4, which sorts out 5-7, which sorts out a 2 here. In fact, that does this whole box. Lets us finish box 9. Now I can finish box 2, and then I've got 2 digits left in box 1. And if I've got this right, I will get a tick at this point. Yes. What a brilliant puzzle. That's so clever. It's so bonkers. But you must have to go through all those evolutions and a vicious 0 here. Imagine if you didn't remember that at the start of the puzzle and you got to this stage and just thought it was broken. Oh, it'd be so cruel. Anyway, brilliant stuff, Rocky Roa, as expected. What a great puzzle. We will see you again soon on the channel. Bye for now.